All right. Sorry, I'm getting my iPad going. Sorry, y'all. Come on, let's go. All righty. All right, so first thing we got to do is we have to balance it. I feel like this is always a class that I have issues with. So what do we need to do to balance that one? Right. Put a 2 in front of that HCl. It was pretty easy to balance. Well, come on, be nice to me. All right, let's see. So we needed a 2 in front of the HCl. And then how many steps was this going to be? Just 2 steps, right? All right. So we did a 2 here. All right, 2 right there. Sorry, y'all. Whew. We don't have enough time for that today to happen either. All right, how many moles of hydrogen? So that's my unknown. Are produced from the reaction of 3 moles of hydrochloric acid. So that's my given. So we have 4 things in this equation, but we're only using 2. So if it helps you scratch out what you're not using. So my given is my 3 moles of hydrochloric acid. And remember, we don't put anything here, or you can think of it as a 1. And I'm trying to convert 2 moles of hydrogen. So I got to follow my units. If I moles of hydrochloric acid here, I have to have the same thing down here because I need them to cancel. So now we've got all that done. So now we're not moles of hydrogen, moles of hydrochloric acid. Sorry. Now we're just filling in our coefficients for our moles. So how many moles of hydrochloric acid do I have? 2. And how many moles of hydrogen? Remember, look at the coefficient. So since there's not a coefficient, we assume it's a 1. Perfect. So my moles of hydrochloric acid cancel. I'm left just with moles of hydrogen, which is what I was looking for. So now we multiply across. So 3 times 1 is 3. Divide by what's on the bottom, in this case 2. And I need 2 sig fig, so my answer would be 1.5 moles of hydrogen. You don't have to put, really what you need on that is moles. You don't have to put what element or compound it is every time. Did y'all get that same answer? Yes? All right, so now we're adding some steps to it. Some are going to be 4 steps and some of them are going to be 5 steps. So today they're going to get a lot longer. So we'll get through those today, and then tomorrow we'll look over that roadmap, and I can show you how that's used because some people will want to use it. Some people may not really be interested in using it. And then you'll have the rest of the class period just to practice. And like I said, what we're learning today is not on the quiz on Friday. The quiz Friday is just what we learned yesterday. All righty. So we're here on our notes. All right. So, so far we've just used the mole to mole ratio as a conversion factor, and now we're going to be using molar mass as a conversion factor. So everything that we're using today, mole to mole ratio, molar mass, dimensional analysis, we've already learned all of those things. We're just putting them together. So remember that 1 mole of any substance is its molar mass. And in these problems, the molar mass is going to be used as a conversion factor. So the only kind of problems that don't use that are the mole to mole problems. Any other problems, the 3-step and the 4-step, they all are going to use molar mass or sometimes 2 molar masses. So just to refresh your memory on what molar mass is, because we've done it before, I'm going to go back to the page before this, and we're just going to look at some examples because it really becomes important in stoichiometry. So you got to be sure that you remember everything about molar mass. So I'm just going to use the equation on this last one because it has an example of everything. All right. So if we would have read that, this is the equation, the balanced equation that we would have written, but we're interested in molar mass. When you're looking at molar mass, you do not use your coefficients. Coefficients are used for mole to mole ratio, but they're not used for molar mass. So the different kind of molar masses we're going to come with is just for a single element. That's a nice easy one. And for a single element, the molar mass is equal to the mass straight off the periodic table. So that's going to be our easiest one. So in this example, that would be aluminum. And if I looked, aluminum would be 26.98 grams per 1 mole. Remember, when you take a number off the periodic table, that's 2 places past the decimal. And none of these molar masses will affect our sig figs. That comes from our given. The reason I've written it like that is because when I write it like this, it looks like a conversion factor that will fit into our dimensional analysis, which is what it's going to become. So I can write it this way, or if I flipped it and need it to write it the other way, it doesn't matter. Those two are equal to each other. Then the next thing that you might see is a diatomic or a polyatomic. We had a couple of those. Remember, phosphorus was by itself. There had to be 4 of them, and sulfur had to be 8. So for a diatomic, I'm not just going to take the molar mass of the element. I have to double that molar mass. So for a diatomic, I'm going to take the molar mass off the periodic table and multiply it by 2. Or if it happened to be phosphorus, you're going to multiply it by 4. Or if it happened to be sulfur, what am I going to multiply it by? 8, yeah. So in other words, if we needed information to use a molar mass of fluorine, that molar mass isn't just going to be equal to 19, which is what you see straight off the periodic table. You have to take 2 times 19. And we'll do one example with that today, so you'll kind of see it more in practice. And then the last one, which we've done most of our work on, is of a compound. So for a compound, you sum up all of the molar masses of the atoms. Once again, I've written too big. I'm going to have to erase a little bit of this, y'all. Everybody got that last part? So my example I'm going to use is aluminum fluoride. So y'all remember that process where we did that? And I would say, all right, I have aluminum and I have just one atom. So I multiply it by its atomic mass off the periodic table, which would be 19. And then F, fluorine or fluoride, I have 3. So I'm going to multiply that by 26.98. And then we multiply it across. So I got 19. 3 times 26.98 is 80.94. And then our last step was we added that together. Grams per mole. Does everybody remember when we did that before? Because it's real important that you know that where that is, because those molar masses are used a lot. Ladies on virtual, do y'all remember when we did that before? Are y'all good on the molar mass? All right, I'm going to take no answer as a yes. All right, so that was just to refresh your memory a little bit. So let's move on to fun in the world of stoichiometry. We'll move back over to the next page and look at our steps. So like I said earlier, we have to start with a balanced equation, because from the balanced equation, we get the mole-to-mole ratio, and that's used in every problem. Every kind of problem, you're going to have to use that. Identify your known, which is what you're going to start with. And also identify your unknown, because that is what you're going to end with. And if you give yourself a start and an end, it'll make it a lot easier. Always start with your known, which is going to be a number that's going to be given to you in your problem. And once you've used that number out of the problem, you're not using that number again. Line up all the needed conversion factors. So that's going to be mole ratio and molar mass. We're not going to do the volume. We'll come back and do that whenever we do gas laws. So for right now, our conversion factors are going to be molar mass or mole ratio. Calculate your problem, and remember you do that by multiplying across and getting yourself an answer, and then dividing by what's on the bottom. And then you want to check your answer. You want to make sure that your units cancel. Everything should cancel except for that very last box at the top closest to the equals. And also check your sig figs. Remember, the thing that's going to dictate your sig figs is your given, because that's the measurement that we are basing our calculation around. All righty. Now that we talked about the rules, let's go, and we're just going to dive in and do the longest one first. So for example 1, this is a mass to mass problem, or you could say it's a gram to gram problem. Mass and gram, those words are interchangeable. And it's 4 steps. And you're going to use 2 molar masses. So that's why this is the longest. You use the molar mass of your given and of your unknown. So when you get a problem that you need to read and you need to decide what kind of problem you're dealing with, because probably the most important thing is going to give you how many steps it is. And it's a lot easier to get these problems correct and get going if you know how many steps you need in the dimensional analysis. I'm going to draw a circle around something, but don't draw it because you don't need to. Remember, each of these boxes are going to be a place for a conversion factor. We're going to start with our given, but then we're going to line up conversion factors. So this is where we'll be using molar masses or mole-to-mole ratios. All right. Oops. my 4 back. All right. So first of all, I'm going to check my equation, and this one is balanced. You have to kind of look at it a little bit, but it is balanced. It says how many grams of copper oxide, so here's my copper oxide, are formed in the decomposition of 6.5 grams of copper hydroxide. Here's my copper hydroxide. So that means in this one, I'm not interested in water. We're still just dealing with 2 things at a time. Okay, I'm going to start with my given, which was I wrote over it, 6.59 grams of copper hydroxide. And then I want to put my unknown, what I'm trying to get to, here top closest to my equals. And we're trying to convert to grams of copper oxide. So if you'll give yourself a beginning and an end, it makes it a lot easier to know where you're going. Remember, we're not putting anything here, or you can think of it as a 1. So now I start following my units. If I'm grams of copper hydroxide up there, I have to be grams of copper hydroxide down here because I need those units to cancel out. So for this box where I have a conversion factor, if I see grams, that's a hint that I'm going to need a molar mass. So down here, I wouldn't have to figure out my molar mass for copper hydroxide. And when you did that, you would get 97.57 grams per 1 mole of copper hydroxide. The number always goes with the grams, and opposite of that is always 1 mole of the same substance. This is not the mole where you look at your coefficients. We'll do that in a moment. So I go to my next conversion factor. I'm moles of copper hydroxide, so I got to be moles of copper hydroxide down here. I look at that box with that conversion factor. I don't see anything about grams. So this is where I'm going to use my mole to mole ratio, which has to be used in every problem. How many moles of copper hydroxide do I have? Just 1, right? And my unknown is copper oxide. So how many moles of copper oxide do I have? 1. I have 1 mole of everything because we didn't have any coefficients, right? Follow my units. If I'm moles of copper oxide here, I have to be moles of copper oxide down here. But I see a gram, so that's my hint. Oh, there goes my other place to use my molar mass. So now I would have to find my molar mass of my copper oxide. Mass of 1 copper, mass of 1 oxygen, add them up, and I would get 79.55 grams per 1 mole of the same compound.
This is Sudoku.
This is Sudoku?
Yes, this is like Sudoku.
This is probably one of the most realistic things that we, oh gosh, I've never got so many text all of a sudden. Stop. Probably one of the most realistic things that we do, because you could use this to convert a lot of things, I mean, around your house, but like in plants where they are making something, they would use this process because they want to make the most money they can. So this process and trying to figure out how things can be put together most economical would be helpful. All right, so now my next thing I'm going to check and make sure that I got all my units canceled. So they should cancel diagonal. Moles of copper hydroxide, moles of copper hydroxide, moles of copper oxide. They did. So now I just need to do my calculator work. Remember, we multiply across. So that's going to be 6.59 times 79.55. I want y'all to try to put that in your calculator, because I would be really frustrated if I did all this work and then my simple thing that made it wrong is I didn't know how to put it in the calculator. So remember, we multiply across. So that's going to be 6.59. I don't have to multiply by the ones, times 79.55. And then I would get an answer or hit equals, and then you divide by what's on the bottom. The only thing I have on the bottom right now is 97.57. Anybody want to give me an answer? 5.37, perfect. And my units would be my last thing I have left here, which are grams of copper oxide. You don't have to write the copper oxide part. You can just write grams. And 3 sig figs, because that's what I started with. So all of this, all of that was from my given. And then the reason we have to use the mole to mole ratio every time is that step is what gets me switched from my given to where I start working the numbers for my unknown that I'm really trying to figure out. So always have to use that mole to mole ratio. I made that one kind of messy. Have any questions about where any of those numbers came from? Ladies, y'all have any questions? All right, let's do another one of those, a long one, and then we'll back off and do a couple of the 3 steps. So it says if excess sulfuric acid, if anything, it says it's in excess or you have enough, that means it's not going to be part of your problem. We all know how word problems, they like to stick in some information. Oh, what did I forget to do that I was just about to start going on and working? Think I did, didn't I? I see I have 2 sodium. So I need a 2 there. And I think I need a 2 in front of my hydrochloric acid. I think that gets me balanced. But yeah, I almost forgot that. That wouldn't have been good. So we have excess sulfuric acid, not important. Reacts with 30 grams of sodium chloride. So there's my given. How many grams of sodium sulfate, there's my sodium sulfate, are produced? So I'm not interested in either one of the acids. So if that helps you, mark that out. Get them out of your way. So my given is in grams, and I'm trying to convert to grams of my unknown. So this is a gram to gram or mass to mass. So it's going to be 4 steps. So I'm going to set it all up. All right, next step. What am I going to start with? The given. 30 grams of sodium chloride. There's my beginning, and then I always want to give myself an end. And I want to convert to grams of sodium sulfate. Now, once I've done that, then I'm ready to just start going along and following my units. If I'm grams of sodium chloride there, I have to have the same units with the same substance down below. So once I see grams, that's my hint that I got to use what? A molar mass, exactly. And molar mass of sodium chloride is 58.44 grams. And per how many moles? 1, perfect. NaCl. Sorry, y'all. Kind of got it wrote too big. Wherever the number is, that goes with the grams, and opposite is always 1 mole. Now I was moles of sodium chloride here, so I have to be moles of sodium chloride down here. I look in that box at that conversion factor. I don't see anything about grams. So this is where I'm going to have to use my mole to mole ratio. Remember, you're using that in every problem. Moles of my known to moles of my unknown, which is my sodium sulfate. So how many moles of sodium sulfate of our unknown do we have? This is my sodium sulfate right here. Just 1. And then moles of my known, which is my sodium chloride. How many do I have? 2. Now we got our 2. Almost there. I'm going to erase this right here. moles of sodium sulfate here, so I got to be the same thing down and diagonal. But I see that grams, so that's my hint. There goes a place for my second molar mass. So I'd have to figure out the mass of that, go through my little process. Hopefully you'll get where you can just do them almost in your calculator. 119.06 grams per 1 mole. Let's see if everything canceled. Grams, moles, moles of sodium sulfate, moles of sodium sulfate. I'm left with only grams of sodium sulfate, which is what I wanted. So now try to put that one in your calculator and see what you get. Remember, multiply across the top and then divide by what's on the bottom. Okay.
So we also multiply in the bottom.
Yeah, so like on that particular one, Angel, I would multiply across and I would get me an answer, and then I would do divide. And since you have two things, you could do them in parentheses.
Okay.
So like on your bottom, you could do parentheses 58.44 times 2, and then close your parentheses. How many sig figs on this one? 3, right. So anybody got an answer they want to share with me? We're still working at it.
2.84.
30 point what? 30.6. Angel, I'm not for sure what you did. Did you? I don't know what you did. Try again. Did you do 30 times 119?
Oh, I was missing the 9 and 190.
Okay. But yeah, I would multiply and I get an answer, and then I do, if I have more than one thing on the bottom, I put them in parentheses. No, that was Mrs. Grimes texting me. She had an uncle that died a couple of weeks ago. And so Miss Baker and I gave her a sympathy card. I have a pile of cards at my house. I just grabbed it. It said, with sympathy. She just sent me a picture. It says, on the loss of your mom. Like, sorry.
Of course.
She said, that's okay. I needed to laugh this morning anyway.
I'm sure he would have laughed this morning.
You're right, Angel. You probably would have. All righty. Ladies, any question on that one? All right, so we've done the longest one, so let's go back and we'll do some 3 steps.
It happens.
It happens. So these are long. To me, they're kind of like a puzzle. I'm weirdly enjoy doing them. What takes the longest is getting those molar masses. And on a test or a quiz, if the compound's real large, I give y'all the molar mass, so y'all don't have to take your time doing that. All right, let's move on, and we'll look at a couple of 3 steps, see if we can't fit them in. All right, on my next one, I have mass to volume, which is the same thing as gram. We're not going to do volume. We're going to save that. So change that to mole, mass to mole. And instead of how many liters of oxygen, let's say how many moles. So mass to mole is 3 steps. You only use 1 molar mass. And since mass is the first thing, that will be the molar mass of your known that you will use. And y'all can take that STP out. That's all about gas. So I do need to balance it, which is a 2 here and a 2 here. And then I think we're ready to go. 3 steps, so I know it's going to be a little bit shorter. Everything starts the same. I start with my given. How many moles of oxygen, so that's my unknown, are used to produce 75 grams of sulfur trioxide. So I'm not worried about sulfur dioxide. So my given is 75 grams of sulfur trioxide. And my unknown is moles of oxygen. So I start my process, grams of sulfur trioxide. I have to be grams of sulfur trioxide down here. So in that first conversion box, I see grams, so that's my hint. I have to get a molar mass. I would do 3 oxygens and then tack on the mass for sulfur. I get 80.07 grams, and that's always opposite per 1 mole of the same compound. Then I follow my units. If I'm moles of SO3 here, I've got to be moles of SO3 down here. So I'm in my last conversion, and it's mole over mole. Am I going to have to use another molar mass? Nope, because that ain't anything about grams. So this is where I just get to look at my coefficients. So how many moles of sulfur trioxide do I have? 2. And for oxygen, how many do I have? 1. And now we do the same thing. You multiply across 75. Well, I don't think you need to multiply 75 times 1. So 75 divided by, and you could put that in parentheses, 80.07 times 2. I got 0.468. Anybody else get 0.468? All right. Yeah, I did all right. Like for y'all to check my math. So even though that's just 1 step shorter, it seems like it's a lot shorter. I don't know why. That one little step. And the very last one is also 3 steps. It's just a flip of this one. So if you notice on that one, I'm going to start with my moles and convert it to grams. So this is still 3 steps. We are only using 1 molar mass again, but since mass or grams comes at the end, that molar mass will be our unknown. And I'm going to tell you, this was a tough little equation to balance, or my mind wasn't awake 3rd period, but this is how finally got it balanced. We're studying stoichiometry now, so while you might need to balance an equation, I'm not going to throw out some really hard to balance equation where you have to waste your time on that. So in other words, I'm not giving you this equation. 3 steps, so we do our same process. How many grams of oxygen, so that's one thing that I'm interested in, is used when 85 moles of ammonia. So I'm interested in both of my reactants, none of my products on this one. So I start off with my given, my 85 moles of ammonia. And then I like to give myself an end, so I want to get 2 grams of oxygen. And then we just start following our units. If I'm moles of ammonia here, got to be moles of ammonia down here. So in that first conversion box, or that conversion box I'm working in, what do you think is going to go here? A molar mass or a mole to mole ratio? Mole to mole ratio, perfect. So how many moles, while I'm on my black pen, how many moles of ammonia do we have? Remember, just look at the coefficient. 4. And then my unknown is moles of oxygen. And how many moles of oxygen do we have? 5. Perfect. Follow my units, moles of oxygen. I have to have moles of oxygen down here. That's supposed to be a G. Oh, no, it looks like something else, but I do have a G. I do have a gram, so I have to use a molar mass. So here's where you would have to remember oxygen's diatomic. So instead of just 16, you would have to put 32 grams per 1 mole. And then multiply across. So 85 times 5 times 32. And how many sig figs is this one going to have? Just 2, exactly. What did we get, Rodney? 3. That's what I got too. It's like the calculator, like it was perfectly 2 sig figs, right? Y'all remember on sig figs, the 3 and the 4 significant, those zeros are not. And we only wanted 2 sig figs. So 3,400 grams of oxygen. So that's all of them, all the different types. So tomorrow, like I said, I'm going to show y'all this, how this works. And some of y'all, it may help, and some of y'all may say that's more trouble than it's worth. If you go home and you're looking at this, we're just using just the very middle portion. We're not using any of the portions that are going out. That has to do with either gas laws or has to do with Avogadro's number. Y'all remember Avogadro's number from last semester? No? All righty, let's call that. I think that's good. So tomorrow we'll go over that, and then you'll have in-class time to practice. And then we'll still stick with stoichiometry on Friday after the quiz. Not too bad? All right, don't forget to get all right, ladies, we'll see y'all tomorrow. Did y'all have any questions? Okay, we'll just kind of keep on with that for the next couple of days, okay? See y'all tomorrow.